Hi everyone, it's a pleasure to be here in Kyiv. I'm loving the city, loving the conference also. If someone can maybe close the door, that would be awesome. So today we're gonna talk a little bit about how we can save the world with JavaScript, or like how can we implement some of the knowledge we already have to solve some of the problems the world is currently facing. So the goal of this talk is to give you a couple of insights and ideas and to show you a couple of cool tools that you can use so people will remember your work and maybe you'll have some impact on the world. I know you like technical talks, I know you like live coding. This is a little bit different, but hopefully you'll enjoy it. So yeah, a couple of things about me. So I work as a developer advocate and front-end lead at a company called Ava. We do a lot of interesting things with data visualization, and we're trying also kind of, to make the world a safer place. I work as a tech speaker for Mozilla. So I speak mostly about open source stuff, the open web, data viz, many cool things you can do with JS, and yeah. So I'm also a conference organizer, a conference called Armada.js. It's happening in Serbia. So if you ever wanted to visit Serbia and you didn't have a proper reason, maybe JavaScript conference can do this. And also, if you would like to talk a little bit about some of the things you did with JavaScript, we have open call for papers. I would love to see people from Ukraine in Serbia. Yeah, I'm working on my PhD in data visualization, so this is how I'm working on it. We'll see where it gets me. And yeah, of course, love JavaScript, and I love CSS. I do crazy fun animations with CSS. So yeah, you can also follow me on Twitter, or you can just type my name or my handle. Daniel said he's looking for 400 subscribers. I'll try to reach 2 million. I'm right now at 400, so let's see how this also works. So what is data visualization? So in a nutshell, data visualization is the visual representation of information. So you kind of get the idea why you should do this properly, right? So why should we do it? So we need to help people understand our information quickly. So we're currently living in a day and age where we're facing many different issues, many different problems, and we have so many data sets, and we're kind of like stuck with them, right? So there's always a proper way to tell a story with that data, and we need to help people understand our information. So like spotting relationship and patterns is extremely difficult if you're not using proper tools or proper visual medium to do this. So people want to see the significance of the data point. And I think something like tools that I'm going to talk to you about today can help you do this. Communicate effectively, telling data-driven stories. Telling stories is always great. You remember when you were a kid, and your parents will tell you always stories, and you enjoy those stories. So I say like there's still that kid living inside of us, and we can maybe do some stories with JavaScript. Yeah, making the world a better place. That's, I think, the end goal, and we should strive to do something like this. So did you know that the beginnings of data visualization are strongly tied to solving some of the biggest problems humanity has ever faced? We're going to go a little bit into history. So this is one of the first examples of data visualization that's known to humanity. So it represents an estimate of the distance in longitude between Toledo and Rome. And it has been created by a Dutch mathematician and astronomer called Michael Florent van Langren in 1644. So what you see here is his collection of the approximation of distance between Toledo and Rome for the longitude by different astronomers and geographers. And so he visualized it. He said, okay, Toledo is on the left, and somewhere on the right is Rome, and the numbers on the bottom represent the longitude. So why did they have to do this? So how is it possible that they just didn't know it? So until mid-1750s, accurate navigation in sea, out of sight and out of land, was really an unsolved problem due to difficulty in calculating longitude. So navigators can always determine the latitude by measuring the sun's angle at noon. And this is something that is pretty straightforward to do. or like measuring from the angle of Polaris, the North Star. But to find the longitude, they needed a time standard that will work aboard a ship. So they had to estimate this. So what Michael Florin van Langeren did, he visualized different estimations, and he said, okay, I see there's some groups there, and I'm going to say that my estimation where Rome is where he wrote Roma. But you see the tiny arrow? That's where exactly it is. But, okay, kudos, he tried. And yeah, it looks interesting, but there was another solution to this problem that wasn't DataViz. So the solution to this problem was a device called Chronometer. And that was the work of one man called John Harrison. He was actually a carpenter. So a carpenter figured out one of the biggest problems humanity has ever faced. And it took him 31 years to solve this problem, but he didn't give up. And yeah, that chronometer like revolutionized naval, later aerial navigation, and enabled the age of discovery. So if you're liking this story, there's a book called Longitude that tells the story really, really good. But you see, like data visualization helped us do something, but there were other examples that maybe prove this point a little bit better. So what you see here is a data visualization by a man called Jon Snow. So if you like Game of Thrones, you'll definitely remember this name. He was an English physician. So what he did, or like what happened, there was a huge cholera outbreak in Soho in 1854. Almost 616 people, I think, died. And they couldn't figure out what was causing this, what was causing the outbreak, why are the people getting sick. So what he did, he said, okay, let's try to visualize on the map where are the people that are infected. So those are the red circles. I kind of increased this because, after all, it was in the 19th century, but you get the point. So he visualized the outbreaks here, and those were the red points. So he said, okay, so what is common with this? So let's see where are the water pumps. Everyone drinks water, right? It wasn't running water like we have right now in our homes. There were water pumps. So he visualized water pumps with these blue faucets, and he said, so the highest concentration, like everything revolves around one water pump. Could this water pump be cause of this cholera outbreak? Maybe. Let's shut it down. And as soon as that happened, cholera outbreak was gone, and people started getting better. No one got sick anymore. And yeah, so data visualization. So today we're facing many different problems. We have Ebola outbreak in the Congo. We have privacy breaches. We have refugee crisis, housing crisis, hurricanes, climate change, humanitarian crisis, human rights violations. I won't say like all these problems are equal. They're not. But this is something that troubles us, and we're trying to find a solution that will improve our life and life of others. So today you have many municipal open data portals where you can kind of get most of this data openly for free, and maybe you can start seeing some patterns like Jon Snow did, and yeah. So visualization is a great way to let your data speak. So what can we do to make this better? So since I'm a JavaScript developer, I'm proposing something radical. JavaScript. Works in a browser, it's versatile, awesome community, that's you. And yeah, so you already know the pluses. So although like you can start blank, and I appreciate that, and you can do everything on your own, there are some tools and frameworks that can actually help you and like speed you up on your projects. If you don't think that this can be the case, so like I will demonstrate a couple of current open source projects and solutions. But as I said, if you don't see there's anything out there that can solve your problems, I'm willing to hear you out, and I would love to see some new libraries and frameworks. It's been kind of slow on that area in the past few years, like regarding how many tools are developed for data viz. So yeah, D3.js. How many of you has used D3.js? Of course, a lot. So yeah, it's an interactive data visualization platform that has like really nice tools for processing database documents. So what D3 means, it means data-driven documents. And it has been developed by a man called Mike Bostock. He currently works, I think, at New York Times. And what is interesting is that he was nominated for an Emmy Award in New Approaches in Current News Coverage. So if you want to maybe win an Emmy, JavaScript. So yeah, it has really, really rich tools for data-driven visuals, very active community, versatility and compatibility compared to some other JavaScript-based apps. But if we're talking about geospatial data, as we saw some of the problems that I described before, they are really, really closely connected to where these things are happening. They're really closely connected to the location, to the world. And if we're talking about visualizing geospatial data and visualizing maybe millions of data sets or hundreds of thousands, I propose another solution. So it's called deck.gl. So what deck.gl is a framework built by Uber open source. And it has a large-scale WebGL-powered data visualization, so it's extremely performant. We'll go into details. It has an excellent layered approach to data visualization. So what this means is it allows you to have complex data visualizations that can be constructed by composing already existing layers, or maybe even create your own layers that can be reusable later. And you are provided with a catalog of already existing layers through the framework. So it has a high precision computation in the GPU, which means it emulates a 64-bit floating point in the GPU. So it renders data sets with high accuracy and performance. Of course, some things that we couldn't do it without is like it has nice integrations. So I say here React and Mapbox GL integrations, but we'll see later how we can integrate it with other frameworks. I'm saying that React and Mapbox because it kind of works the smoothest with them, because Uber built this deck.gl with Mapbox.gl because they don't use Google Maps, and with React because they use React. So yeah, when I'm talking about deck.gl and when I'm talking about some of the solutions here, I'm not going to say those are the best solutions. No. Those are the solutions that can help you solve the problem. So like if you see that it's not working for you, cool, fine. But I'm here to explain why you might want to use them. So when we're talking about resources, there's of course the official website, and there's a lot of examples, documentation, showcases, blogs, links to the GitHub repository you can find. So as I said, like it has an interesting layering support, layering instances. So these are a couple of examples with some of the core layers they have. There's many others. I just visualized here scatterplot layer, arc layer, text layer, marker or like icon layer, so you can see how this looks roughly. So if you used D3.js in the past, you know that when you're instancing something you want to draw, whatever it is, let's say those are some circles with a certain radius, you have to separately instance the data and separately instance the drawing, and then you have to have a function that will map the data to, let's say, the radius of the circle, etc. And this is a little bit complicated for us. But what deck.gl does, it's wrapped around WebGL, and it has and in WebGL 2, there's a nice feature called instancing, where you can very cheaply create visual objects, clone it, tweak it, and yeah, it has a really nice performance. So as I said, like you can use already existing layers, but you can also extend the layers. You can write your own shaders, but don't do that if you don't really know what you're doing, so you can end up with like real low performance with this. So I'm going to show you a couple of examples how this actually looks. So keep in mind that some of the examples that I show might be a little bit laggy because I'm running tons of stuff while I'm recording this, and the screen recorder on top of it. It will run a lot smoother on your phones or on your PCs you're just running this. So here we see a solution, like a visualization of every person in New York City. So each dot represents 10 people. So this is 2015 census data. And we have some filtering. We can check male, female, radius, and yeah. So what you see here is an excellent sync for the overlaying data and the map itself. So as we are panning, tilting, zooming the map, the data, or like the overlaying data built in deck.gl syncs with the map. So like you don't see any discrepancies there. So it reflects this perfectly. Here, you see a very interesting visualization. So like it's a yellow cab versus green cab trips in Manhattan. I hope you see the difference. There's green lines and red lines. The light is a little bit strong. But those trips are taken, I think, in 30 minutes. So 30-minute range, they have 10,000 trips. So for 30 minutes, 10,000 trips are happening in New York. So you see here that we're visualizing 992,000 vertices in the browser in real time, so you can actually interact with all of these things. And of course, you see buildings in 3D, so this is a really nice feature provided by Mapbox. So I don't know if you know, but Mapbox is built on top of OpenStreetMap data. So OpenStreetMap data is something that the community can add stuff there, but if the buildings there have their third dimension, you can actually visualize these things in Mapbox, just extending just adding one more layer, building layer, and the buildings will be represented really nicely with third dimension. If these buildings don't have the third dimension, it will just average them like default size, so everything will be kind of same height. But yeah, as you can see, this works really, really nicely with the map, and you can see the animations, you can see those vehicles, those cabs are moving, etc. So what it has a really nice real-time data aggregation and filtering. So here we see road safety data in Great Britain from 1979, personal injury road accidents. And what we are doing here right now is we're actually changing the filters here, and you can see how the data looks. So like this is running in real time in the browser, and you can actually change the visualization as you like analyze the data. And maybe you want to have some dense data, maybe you want to have something like specific filtering. These are some basic filters. But as you can see, we're visualizing 140,000 points in the browser. We talked a little bit about custom layers, and this should start. Okay, the video should start. Okay, what we have here is the wind map of the USA. This is a little bit tricky to build. But as you can see here, we have here 3 different layers. I won't go into details how these layers are built, but you can see that there's some visualization like difference in height, and the difference in the wind speeds and the wind direction. And this is all working in the browser, so like millions of points are currently visualizing. You can see the concentration of the wind. This example was built by Nico Belmonte. He was at that time working at Uber. He now works at Mapbox. But he actually created 3 layers that he thought that could help him to visualize this problem, extended already existing ones. And yeah, so this looks kind of cool. I will explain later a little bit why visualizing wind might be really helpful to save the world. You can do a lot of things with animations. So still browser, not a movie, not a scene. But if you're not into map-related data visualization, you can do something like this. So what you see here is, I would say, a building / some kind of duplex apartment. That was, I would say, like recorded with something called LiDAR. So who knows what LiDAR is? Okay, cool. So a LiDAR stands for light detection and ranging. So it's a surveillance technique that scans the surface using laser light and returns a densely populated 3D point cloud. So LiDAR lets you answer many different questions that were previously really impossible or impractical to answer. So for example, you can calculate the precise tree coverage around every building, let's say on an island. Why is that important? So trees are national windbreaks, so they reduce the damage caused by hurricanes. So FEMA uses LiDAR for analysis as they plan for the upcoming hurricane season. So imagine combining this LiDAR data for these trees and combining them with the visualization that we have for wind speeds and like some wind estimations. We can actually, wouldn't say predict, but we can assume what areas of the island will be most affected. And we're still doing this in JavaScript. So, if we're talking about visualizing things that are not map related, you can use deck.gl, of course, for it. It's 3D, it's canvas, doesn't have to be connected with a map. So if you think that you can have benefits of something like this, feel free to use it. There will be later a couple of examples that will demonstrate this. But to continue, how does it work? Okay, so you're interested in how you can use this framework and how you can build upon it and how can you create some interesting solutions. So let's say you have your web app. Let's say it's React, Angular, Vue.js, doesn't matter. And you have some map. Let's say you're trying to visualize geospatial data. And you're using Mapbox. Okay, you might want to use Google Maps, totally fine, just as an example. So if you want to use Mapbox.gl, it's actually excellent that I'm in Ukraine. You know Vladimir Agafonkin, he worked for, like, built Leaflet, so now he's working at Mapbox, Ukrainian guy, really respect that guy. So actually, like, you have to have a wrapper around the library itself, so the wrapper can be for React, Angular, or Vue. And then you're going to use deck.gl for visual overlays on top of that map. So the integration between deck.gl and Mapbox is really nice and really easy to implement. Of course, there are some frameworks that can help you with this. And underneath, there is something called Luma.gl. So what is now Luma.gl? Luma.gl is also companion framework to deck.gl, built, of course, by the guys from Uber. So it kind of represents an ES6 code base that works as a wrapper around main WebGL 1 and 2 entities. So it's WebGL2 ready. So it has textures, transform, feedback. Interesting thing, if you want to learn more about WebGL, you can start reading a little bit how Luma.gl actually works, because it wraps around some of the main features, and you can maybe get a glimpse of how this works on a higher level of abstraction. So let's say you have your React app. I can assume most of the people here use React. That's at least the stats from Stack Overflow, although I'm mostly Angular developer, but yeah. So yeah, you have your React component, and within it, you have your data. And you want to do something with your data. You want to show it on the map. So this data gets passed to deck.gl. So if you want to visualize your data with a map, you're gonna have to have some map wrapper around your mapping library. And that's why on the right we have something called React Map.gl. It's a framework, works really nice with deck.gl and wraps around the Mapbox and deck.gl together. So like you can use deck.gl with Mapbox. So I said here React Map.gl. You say, okay, I'm using Angular. What will I use then? That's the thing. So if you're using Angular or Vue or any other framework, there's not a lot of companion frameworks like React Map.gl for those frameworks, but it's not that difficult to build something your own that will work for your purposes. So it's not a problem. It will take a little bit more time, but we're not talking about months. We're not talking about weeks. We're talking about a couple of days, depending on how complex you want to build this. So what is happening in deck.gl? So you see something called Layer Manager. So what Layer Manager does is it manages multiple layers. So let's say you're passing GeoJSON data to deck.gl. How many people know what is GeoJSON? Okay, so you know how many people know what is JSON? Okay, cool. So difference between JSON and GeoJSON is just subset, I would say, like superset of JSON, where you actually can have different data types to visualize things on the map. So you have coordinates, you have different layer types, still JSON, just a standard. And you pass that GeoJSON and say, okay, so I have this line, and I have these points, and I have this polygon. So these are all different layer types in GeoJSON. So when I pass this GeoJSON as one file to deck.gl, what deck.gl does, it separates through Layer Manager these different layer types, and this works a lot faster. So you actually had, like, it has its own computations to calculate point layer, polygon layer, path layer. So this happens all behind the scenes, and you don't actually have to know a lot about it. And underneath, LumaGL does its thing with WebGL. So if we're talking a little bit about the integration and how everything works with one another, here, let's say we want to visualize arcs and scatter plots on top of a map that's going to have buildings in 3D, something similar we saw in the example before. So we see here on the bottom, we see a Mapbox label layer and Mapbox building layer. So these two things combine together and go into Mapbox GL canvas. So you have your map. Same thing with Google Maps. But you want to also visualize something in deck.gl. So deck.gl wraps around its arc layer and scatter plot layer and creates a deck.gl canvas, and you have a DOM composition of these two things. So someone can say, this is slow. I agree. It is slow, and it has other problems. So the intersection of these things might not be the best. So what the guys at Mapbox did from some of the releases, I think maybe a year ago, they enabled third-party layers to draw into the same WebGL context as Mapbox's map is rendered in. So what you actually can do now is combine all of these things together into a shared canvas. So what this offers is deck.gl GeoJSON layer can be inserted in between Mapbox's base geographic and label layers, so that the filled polygons so the filled polygons no longer cover the map labels, which is cool. But also the arc layer and the buildings layer can cohabit in the same airspace, so they're correctly obscuring each other. What this means, let's visualize it when I'm talking. Doesn't make a lot of sense. But you can see here that actually the arc layer is not going through the building, like it's stopping there. Like you can actually see this interaction. You can see the scatter plot is between the map itself and the building. So it's not on top or something like that. So sharing the context works. So let's go a little bit into the code. Not too much. It was lunch. So how to use it with React, basics. Who can figure out what this is? Everyone, I think. You're importing the basic things you need for your React project. So React, deck.gl, and we're adding line layer. Let's say we want to visualize one line, nothing much. So we're importing the layer, and we're importing our map from React Map.gl. So we need to set a couple of initial values for the map. So if you're using Mapbox, you're probably going to have your Mapbox access token, and you're going to have some initial viewport settings. So you don't have to have this, but I can assume that if you're visualizing something on a map, you want to be pointed into some certain city, not just anywhere. So let's visualize the map. Let's say we want to start at this longitude, this latitude, zoom, pitch, bearing, longitude and latitude. Who knows the difference? What is longitude, what is latitude? Okay. Yeah, so it might be this, it might be this. Okay, cool. So yeah, read the book. So yeah, you can set the zoom, you can set the pitch, you can set the bearing, whatever you want to visualize initially. And let's say, okay, we want to have our line drawn. So what line has to have? It has to have a starting point and an ending point. So those are two coordinates. Latitude, longitude for one, latitude, longitude for the other one. And this is just data array, simple array. So let's visualize this. So we have our React component, and we have our line layer. So we're just having a constructor for our line layer. We added some ID, and we pass it the data that we saw before. So what we want to return as a result of this component is our deck.gl enabled, enhanced map, I would say like that. So within deck.gl, we see some initial view state. That is the thing we shown before, the initial state of the map. We pass the layers, and the layers itself is just one line layer. And we add our map. So it kind of, the map is within deck.gl, but it's kind of wrapped around. And that's it. You drawn a line onto a map with React. Simple stuff. So if we're talking about something more complex, similar approach, more things and tricks to do with the layers, more things and tricks to do with the data, with the GeoJSON, how to optimize the data, etc. Using it with Angular, this is really basic example, just one function that I wanted to show in my presentation that I will, of course, link later on my Twitter. You can actually see the links to all of these examples. You can get the code, full-fledged code that actually works, not just these snippets, but you can also copy these snippets. So basically, we're just creating one more map box layer through deck.gl, passing the data. Let's say we want to visualize taxi trips, and set the opacity, stuff like that, and we add this layer on top of a map. This is one implementation that's available on GitHub. As I've said, the framework as React map doesn't exist for Angular, but you can always do something with it like this. So I hope you have QR code scanner. You can scan it. I'm not hacking you, I promise. So what you see here is actually an interesting visualization of the, okay, let me just do this. Sorry. What you see here is something called a flight map. So it's an example built with React and deck.gl. So it should work on your phones. I tested it in Android, iOS, Firefox, Chrome, Safari. I cannot guarantee it will work smoothly on all of your phones, but you can actually see the visualization of the map. So like Flight Mapper is a website where you can actually put in your data. So let's say you're flying often or you're traveling somewhere, it doesn't matter, and it visualizes where you went from one point to another in which point in time. So you can run it on your phones, you can play around with it. So it's built with React and deck.gl, and there's a link here to the project itself. If we're talking about Angular, similar approach. Like you can also scan this QR code, so you're going to see how this runs on your phone with Angular and with deck.gl. So here we have two layers. One is the buildings layer, and the other one are these trips. So the example that I've shown you with Angular code before, it's from this example. So as you can see, I hope it runs smoothly. Does it run on your phones? Yes? Yes? Cool. OK. So real-life examples. How can we do it without them? So here we see a tool called Kepler-GL. So it's a powerful open-source geospatial analysis tool for large-scale data sets. It's built on top of deck.gl by the same guys from Uber open source. But of course, same as deck.gl, Kepler-GL is available for everyone to use, and you don't actually have to be a programmer to use it. Like if you have some data analysts, data scientists in your company, they can actually import their own data in GeoJSON, let's say, and they can visualize it in the browser. So you can actually build your own projects on top of even Kepler-GL, or you can just extend deck.gl, and you can do a lot of filtering, et cetera, et cetera. But the most interesting project is this one. What you see here, it works in the browser. This is browser. I always have to repeat that because people don't believe me. So this is autonomous visualization system, a framework called Streetscape-GL. You remember the story about LiDAR and like how you can scan things with light, with lasers, and you can get the shapes of the object. So this is one approach how those autonomous vehicles work. It's not the only approach. There are several approaches, but this is one. So a vehicle has a LiDAR on it, and LiDAR deflects and collects the data. So the car can know where it is, or like what is his surroundings. And of course, when we train these systems, we can detect, in our software, we can detect what is a bicycle, what is a car, what is a truck, what is a pedestrian, etc. And Streetscape-GL does an interesting thing. So built on top of deck.gl. So every visualization that you see here is deck.gl. So that's why it has this performance, and you can visualize so many different data points. And you can interact with them. You can actually click on this bus. It's not a video. So what it does, it consumes the data in something called XViz protocol. And this is a protocol built by them from Uber that allows you to have some log viewing, simulation, and debugging in a web-based application. So if you're a little bit interested in what you can get from the XViz protocol, this is something like this. So you can have a velocity, acceleration, state of the shift, or like turn signals. Are they on? Are they off? Is the driver currently listening to music? This might be interesting to analyze. What is the HUD? What is, acceleration, metrics, etc. So it's basically XViz an abstract visual world state description format that can be updated incrementally and with complete snapshots. This is one more example. Still deck.gl, just looking a little bit different. We kind of added color. Color is nice. But there are solutions by other companies, of course. This is something that is fairly new, so not still a lot of things being developed with it, but it's slowly getting there. So there's a company called Foresight AI. So what they are doing is they're kind of building a data platform for autonomous mobile robots. They call it like that. So their goal is to build the world's largest driving scenario database for training and validating automating driving systems. And this is built on top of deck.gl. So you can see the similarities between this and Streetscape.gl, but they built this before Streetscape.gl, so kudos to them. And again, if you just want to have fun, there's something like this, which will hopefully start running. Okay. So you can do cartoons with deck.gl. So yeah, what it does, it uses a text layer API to convert pixels into characters on the fly, and it's WebGL2 compatible. So you can see I'm changing the font size. Deck.gl still. So if you'd like to do something like that, I would really love to see that. So a couple of references. Yeah, so we have our, of course, main website that I mentioned. There's a good portal called WebGL, and it's really, really interesting because it's basically a medium profile that all the guys from Uber data visualization, they have always those interesting projects. It's not just connected to the frameworks they build, it's connected to how they visualize data, and there's some also interesting math. If you're into math, there's always some interesting solutions there. Yeah, a couple of things that I've used here are from Nico Belmonte. He has an excellent video on YouTube called Visualization Nights with deck.gl. A lot of cool examples. Leger Lee from the Uber Open Source Summit, how Uber does their frameworks. Xiaoyi Chen, excellent blog on data visualization, one of the best I have to say when we're talking about web and JavaScript. Interesting things always there. If you like the story I told you at the beginning, like the Michael Van Florent, Latitude, Longitude, Jon Snow, there's a guy called Michael Friendly. He's a professor at York University, and he's fascinated by data viz, even more than me. And he spent significant amounts of his life to something called Milestones Project, where he actually collected all the data viz that humanity has ever produced, and like he's still collecting it. There's always new things to find, there's always new resources, and there's always an interesting story behind every single one of these data visualizations. So if you're interested into that, check it out. A book from Alberto Cairo called The Truthful Art. I don't think, I always love conferences because we're always talking about books at the end somehow, and someone always has a good recommendation. I would like to recommend this one. Alberto Cairo is probably one of the leadest experts in data visualization in the world. He worked with many, many companies, many different organizations, biggest ones in the world. And his book is basically saying how can data lie to you and how you can make sure that this doesn't happen, or like how can you create truthful visualizations. It's an excellent book. I really recommend it. And something that's not connected so much to, I would say, programming, or JavaScript or data viz, but it's connected to the source, to the data. A book called Factfulness, 10 Reasons Why We're Wrong About This World, by Hans Rosling. So the kind of book tells you a story of how our perception of the world might not be entirely correct, and where the humanity has been and where the humanity is going. And it's an interesting story, many interesting stories in this book. And whenever I read this book 3 times, and whenever I read it, I kind of feel good about humanity, because in the news, you're always seeing some bad things, and I don't like that. I don't read news that much, if they're not JavaScript news. But this book kind of helps you get a better grasp of the world. Recommend it. Of course, Mapbox blog, Nightingale, Data Visualization Society started this really recently, so yeah, you can always find something there. So next time you decide to do some JavaScript coding thing, think about how your code can impact the world and use it for good, not evil, and save the world, and follow me to find out more. Thanks.
Questions?
Feel free to ask. Don't be scared.
Thank you for a great talk. Maybe you can recommend some solution for saving already rendered the tree chart as a PNG. Because when it's become large, about 5 megabytes, it's breaking when downloading.
Okay, so you want to find an alternative to D3?
No, I need a solution to save this rendered tree map as a file. Because some solution like image saver or file server sometimes run out of memory, maybe run out of memory,
okay.
And save this as a file is not possible if it's big.
You're overlaying some kind of PNG on top of a map, right? Like something
no,
on top of a map.
I have a big SVG,
SVG. Okay,
chart
okay.
with images embedded, and I need to save all of this content.
Yeah, there are interesting approaches to this. We actually we did something similar. So what I didn't tell you about is the performance limitations of deck.gl. So there are limitations. It's not unlimited, right? So if you're trying to visualize a couple of hundreds of thousands of points or something like that, this can work really nicely. If we're going into a couple of millions, we're still good. But if we're going above that, it might be problematic. So if you're trying to visualize something like, let's say, PNGs or SVGs or something like that, like on top of the map, deck.gl cannot help you a lot with that, but D3 has some nice plug-in frameworks for it. So I can actually share this on Twitter later. So you can actually get some better performance on that. But to go back at the performance limitations, which I know that people are interested, if we're talking about how to visualize billions of data points in real time in the browser on top of a map, deck.gl cannot help you. But you can build something interesting. So let's say you want to have your data back fast. You want to be filtered by location, by time, by some different filters. You'll first have to have a really interesting database, and I would say some in-memory database, and you'll have to build a rendering engine. Rendering engine on the back end that you can use to render a PNG that you can display on top of the map, and then you can interact with the map with that PNG. So this is also something that can extend the performance of your solution if we're talking of visualizing billions of data sets. But also, if you have to visualize billions of data sets, ask yourself why. Okay, yeah, feel free.
Thank you for presentation. Could we change Mapbox to leaflet?
Yes. Could we change Mapbox to leaflet? Yes, we could. That's the answer. Yeah. Actually, like, you would probably, when you're talking about leaflet, you're probably talking about using OpenStreetMap data, not the paid version, right? That's the only reason why you would use it. Yes, you can, but I actually haven't tried this with deck.gl. But I know that a couple of people did, and it worked before. I'm not sure what is the current state of it, because you know itself that Mapbox extended leaflet significantly. Although his leaflet is currently supported and everything is fine, and you can use it with OpenStreetMap data, I'm not sure how it will work with the shared canvas thing, but I think you can do something. JavaScript developer, we can do everything.
Hello, thanks a lot for a great presentation and of course visualized data. And I have a question, did you try to build the same nice graphics and maps using JSON only with pure OpenStreet API, without any wrappers like leaflet, Mapbox?
With OpenStreetMap data?
API.
API, yeah. What we do at Ava is we visualize some, I would say, safety-related, interesting things around the world. And we are actually getting data from the OpenStreetMap. And from the API also, we're visualizing everything in real time, but we're not using deck.gl for this, because it's not a lot of points that we're visualizing, I think. So yeah, we tried, we did it, but usually we use just a default canvas for this and like WebGL, some basic stuff. We don't use deck.gl. Like you already have integrated in the frameworks itself the ways how to draw something. So is that okay?
Thank you very much for your speech. I have a question. I don't know, maybe if it's kind of stupid, but if you're talking about billions and trillions of points, is it possible to do it like you have a fixed zoom, fixed point of view, and like fixed amount of points, and all the rest should go somehow like the lazy loading? When you change the map, you recalculate. Is it possible to have always the fixed range of points connected to this to your zoom and point of view? And it's like no matter what is left of the map, because it's like should be recalculated with lazy loading.
Yeah, you're kind of correct on that. It's not a stupid question. My professor always told me there aren't stupid questions, there are only stupid answers. And you're right. But when we're talking about visualizing things, I'm always kind of connecting it with interactivity of that. So let's say you want to have billions of data points that are visualized, but you want to have an interaction with each and every one of them. So lazy loading, not going to work, because of course you can interact with some, but how would you know with which ones you can interact, right? So the only way would be a rendering engine, and then when you click on it, you're not actually interacting with it, but you're kind of simulating the interaction through your backend platform. So like you kind of simulate the click, sends the position, and gets the data back. But for this to work fast, you have to have like in-memory database probably.